Okay, so Shlok, can you see my machine?
Yes.
Okay, so to everyone else as well, मैं क्विकली तुम लोगों को बता रहा हूँ कि VS कोड पे कैसे करना है, ठीक है? जस्ट इन केस तुम लोग, क्योंकि बहुत लोगों के डाउट्स भी आ रहे थे। फर्स्ट ऑफ ऑल, इसके लिए जीपीयू एक्टिवेशन नहीं चाहिए, जो हम अभी करने जा रहे हैं, क्योंकि इसका ईपॉक यानी द फर्स्ट ट्रेनिंग स्टेप, और आई मीन ईच ट्रेनिंग स्टेप इज नॉट दैट लॉन्ग इवन ऑन द सीपीयू, ठीक है? सो अभी आपका सेशन स्टार्ट हो चुका है, जस्ट इन केस यू डिडंट नोटिस। अब इसमें थोड़ा सा ध्यान देना है कि अभी मैं आपको पहले बता रहा हूँ सेटअप कैसे करते हैं, देन आई विल टीच यू द रेस्ट। थोड़ा सा ध्यान देना, बीच में पूछ सकते हो, बट आई प्रेफर कि अभी ध्यान दो। फर्स्ट ऑफ ऑल, you have to go to the extensions tab and search for the Jupyter extension, ठीक है? Jupyter notebook का extension है, जो आई थिंक Jupyter notebook का extension है। एंड ओके, लोड होने में टाइम ले रहा है। या सो Jupyter notebook support मेरा ऑब्वियसली इंस्टॉल्ड एंड enabled है, तुमको भी ये करना होगा, ठीक है? This makes VS Code capable of running IPYNB files, जैसे श्लोक you just asked. Okay, so I'll talk about the rest of the files in a bit. पहले ये कर लो, ठीक है? और बिफोर डूइंग दैट, या उसको कर लो स्टार्ट, ठीक है? मैं आप लोगों को क्विकली बता देता हूँ कि जुपिटर नोटबुक के लिए, look, there are two kinds of environments in Python. So first is conda, ठीक है? मैं conda यूज नहीं करता, so I'll teach in the one I use, which is virtual env. So what is virtual environment or virtual env? This is not a virtual machine, not to be confused with a virtual machine. This is just an environment. देखो, when you use libraries such as TensorFlow, Matplotlib, NumPy, right? You have to, install those libraries, correct? But imagine this: you have Project A and Project B. Project A is using some version of TensorFlow, say, I'll just use simple version, say 10, and then Project B is using TensorFlow version 9. First of all, why would you do this? Because some functions may have been removed from the newer version, may have changed names. You don't want to rewrite the whole code, right? So this is why you're using separate versions. Now, what will happen if you just directly go pip install something? I'm not going to do it, but if you directly go pip install something in, say, TensorFlow, so it will install TensorFlow, the same version, throughout your laptop or device. Okay. Now you won't be able to differentiate between both the versions. Okay. So what we do for that is we use virtual env. First of all, for throughout the device, you have to install virtual env. So it's just pip install virtual env. Okay. I have it installed already. If I just click this, it will say requirement already satisfied. Okay. So let me just clear the screen. So once that is done, you just type into your terminal virtual env and then the name you want to give your virtual environment. As a convention, we give the name .virt. So I would write .virt over here and press enter. I'm not going to do that right now because as you can see, it is already made, right? So once you do that, to activate it, you just have to go .virt/scripts/activate. Just in case you have a Mac, you can do this on Collab for now. The same script works for Macs as well, but this activate functions uses some bin command, which I'm not currently aware of, and most Windows users will never be aware of. So you can obviously see one. You just search for virtual environment Python, and you'll get the command. Just you just have to copy paste it. Okay. But you can for now use Google Colab. Again, Google Colab की memory खत्म होने की कोई issue नहीं है, because this will not use, like, this will use a very light amount of memory. Even GPU connection is also not required for Google Colab. You can just use it as normally connected. Okay. So this is because the CNN is just one line of a model. Not too many layers are there. The more the layers, the more the computation time, the more you have to, give it computation power to reduce the time back to the time it is. Okay. So that's all about virtual N. Once it is activated, you just go pip install, right? Just pip install and then write the names of TensorFlow and comma matplotlib, comma numpy. Okay, it will install all the versions. There's no issue of getting the newest versions right now. Okay, once that is done, then over here you can select the virtual environment. It will come over here as with the name that you have given it. It's .virt for me and it's already selected. So this is how you will set it up on your local machine. Okay. So if you have any doubts, I'll be first of all shifting back to the Google Colab screen and you can ask me those doubts. Shlok, quickly just tell me if you understood. You know?
Yeah, I understood.
Yeah.
Process.
Okay. So I'll give you one more. I think you could have just easily followed. So I'll give you till 9:23, right, to just set it up if you're doing it on that. Otherwise, you can just upload the IPv4 file on Collab and it'll just work fine. But I would suggest trying it out on VS Code. You can, because you can ask me the doubts. The first time I made a virtual environment, I got very, very confused. So running scripts is disabled on this system error. So first of all, I'm hoping that you're on the administrator server and you have to write scripts and the S is capital for scripts. I would suggest just going on GFG and copying the look. I'll just look it up for you. See. So you can, okay, so pip install virtual n, right? This is the name and this is for, I think, Python and all. You just go scripts, you just go virtual n slash scripts for Mac, and this is bin for Linux slash activate. Now, right, so you have to write the, I'll just use dot virt slash the S has to be capital and then pi, scripts, and it has to be plural again and then activate. This should work for you. Right? Virt scripts slash activate. Showing an error. Okay, if it's still showing you an error, I'll fix it after the session. If you can contact me, right? I think your system might not have given the adequate permissions to that folder, right? And you've created the virtual environment before this, right, Fazan? Fazan, just quickly write. Yeah, so you've created it, right? Okay, so no issues. Just upload this IPYNB file on your own collab notebooks, right? It shouldn't take that long. Uh, Again, you
So
can
yeah, I had a
just
question.
go. Yeah,
Uh, yeah, what would you suggest for beginners, like to use Google Colab or VS Code?
I would suggest using VS Code. Because otherwise, these doubts that are arising right now, like you are facing errors in a very basic thing, which is a good thing because if you don't face these errors right now, then you'll face them in your companies, which will be a bigger issue. So use VS Code. I'm using Collab right now because I'm collaborating, right? So I'm using Collab right now to just show it to you in a very, very easy way, but all of you need to learn how to run these on VS Code. But for now, if just in case you're facing an error, just upload it on Collab and you can run it perfectly fine. I'll show it to you. I'll run it in front of you.
Okay,
In
thank you very
case,
much.
okay, in case, just in case, I hope this does not happen, but मतलब बिल्कुल ही backup में if it does not run for you, it's okay, understand right now. Then ask me on DMs. I'll try and help you out. You can ask anyone, Ambermani, me, Rajat, right? Just ask on the Season of AI chat. We'll help you out, and you can do it later with the recording of the meeting. Right? But try to do it right now. I think uploading on Collab would just solve all issues. Okay, so I'll wait till 26. Wait. Shlok, you have a doubt?
या वो आपने वर्जन कंट्रोल वाला अभी बताया था ना कि हम लाइब्रेरीज के वर्जन के इंस्टेंसेस क्रिएट कर सकते हैं अलग प्रोग्राम्स के लिए,
हाँ
वो
हाँ
वाली
हाँ
चीज एक बार आप रिपीट कर देंगे प्लीज?
Yeah, okay. So, एक second, let me just shift the sharing again. I know it's a bit annoying कि मेरे को shift करना पड़ता है, but करना पड़ता है. Anyway, so, okay, so Shlok, do you remember the virtual environment thing, right? Virtual n dot the name you want.
या
Okay, so I've already created dot virt. Okay, now let's try something else. I'll just use this to create another virtual environment. I'll name it my word. Okay, so it's created my word. Okay, I'll just clear the screen because this is annoying. Okay, so my word is created. Now this is separate from .virt. So let me first activate .virt in this terminal. Just notice I'm not activating it for IPYNB. It's still on the .virt. I don't want to mess that up right now. I'm just focusing on this terminal. I'll just activate this. Okay, so this has been activated. Now say I'll just write pip freeze. Okay, so these are all the versions of things which, by the way, pip freeze just shows you all the versions of every library installed, right? So these are all the versions of stuff installed on this .virt environment, right? Now
ओके
I'm using, okay, so I'm using some versions, NumPy is 1.26.4, right? Now, for example, I'll just do this. I'll copy this and we'll use this later. So first of all, I'll just deactivate. I've, as you can see, we are outside of the environment. Now I'll activate my bit, the other environment. Okay, so we are in this. Now I'll write pip install, say 3. I don't know if this will install. I'm hoping this is a version that is available still. Yeah. Okay, so see, it's installing this. And some more differences will be shown to you because as you had seen previously, I had already installed TensorFlow, Matplotlib, all of them into the .virt thing. Right now, if I write pip freeze, see, only one library is inside the myword, right? So this is how we are controlling the versions of the libraries in our laptop. Exact version control is done by Git by me. I mean, there may be some other version control softwares. But in this instance, the version control you were asking about was about libraries. So that's how we control the version. Now, if I deactivate this and go back into my, okay, I'll just edit over here, .vertex environment. And if I write pip freeze again, it'll again show all of the libraries that are over here. Okay, I think that should have solved your doubt, right? Okay, you have to tell me. Hello.
या
Yeah. This, do you understand it now or?
या इट्स क्लियर नाउ, थैंक यू सो मच.
Okay, thank you. So I'm going to assume it's 9:30, so I'm going to assume that you all have it set up on your Google Colab. So we'll be starting right away. First of all, just 1 second. Okay, so I'll be teaching it to you on collab also, okay? So you guys can follow through very easily. Okay, I'm hoping that I'm sharing the screen, right? I must say that it
Yes, it is visible.
Oh,
It's
thank you. Yeah, okay. Thank you. Thank you. Okay. So thank you, Shivan. Thank you. Okay. So this is I mean I've put my name over here as well. Okay, so this is the basic model, not to be intimidated, and I'm sure many of you have already made a model because you had to upload a model for week 2, right? But most of you are still learning how to make models. Not to be intimidated by any of this. The only few lines of the model are these two, right? I mean these three, and I'll explain each and every line of what's going on. Okay. So first of all, let's talk about the MNIST dataset. Okay. So if you go to the TensorFlow datasets site, right? TensorFlow.org datasets, anyways, catalog slash MNIST. MNIST is basically a dataset of handwritten numbers. This is used for computer vision purposes. This is first of all used to teach computer vision, and then once you learn computer vision, you can use it in real life practices, right? And the model I've given to you is very, very easy to train and very, very accurate. And you can also, upload your own image and then load it into the model, and you'll see that it is able to predict that it's, 4, 1, 0, whatever, right? So what is this trying to tell you over here? How do you read this documentation? First of all, you need to learn all this because in the future you'll be able to do it by yourself as well. So this is again the dataset size, download size, that does not matter. So the split, which is done automatically. Okay, so one of the best things about all these MNIST datasets, you can see there are so many. In fact, in the video provided to you by Microsoft Learn, student community, it was the fashion MNIST video, right? It may also be over here somewhere, right? It's on this website. Oh yeah, there it is. So yeah, all of these are already provided, and pre-processed by TensorFlow and then already split as well. So loading these data sets is very, very easy. What does this tell you? This tells you that there are two labels, right? Imagine this as a dictionary. So for every image, there's an image which has the shape of 28 by 28 by 1. Let's ignore the 1 for now. 28 by 28 is basically the pixel size. So 28 height and 28 width, right? And then what is the one? One is basically one represents the RGB value, right? I mean, not the value in this case. One basically means here that this is a grayscale dataset, as can be seen over here, right? These are all grayscale pictures. And there's no need to worry. Your model will also be able to, if you write with a blue pen, it will be able to predict it. You can use this model that I've provided to you and upload your own photo. Okay, and then label is the class label. It's just like for 4, the label is 4, right? So that's how the labels are given. And the split you already know in between training and testing. And I've already told you in the first few sessions of basics of AML that training is used for training the dataset mm, through which the model learns, and testing is used to evaluate the dataset, right? So this is how it works. This is the very basics of MNIST. And then the famous video that we've shared with you is based on fashion MNIST. You can also learn about that. Again, this is in grayscales. This is also used to learn for CNNs as well and for GANs as well, right? You can use both as GANs, obviously, because where there are images, there are GANs and CNNs. Okay. So, yeah, these are the MNIST datasets. Now let's come back to the model. So first of all, we've imported 3 libraries: TensorFlow, as TF. Okay, so first of all, as TF, as Plyplot, as PLT, as NP. These are basically pseudonames, right? Because every time you don't want to write TensorFlow dot blah 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 blah, you just write TF dot and PLT dot and NP dot. So we do use pseudonames, right? Uh, okay. Just a second, it takes a while to. This is why I want to, by the way, use VS Code. It's a lot quicker. Anyways, so we'll be using TensorFlow for the neural network, and NumPy for making and modifying the arrays, and Matplotlib for making figures and graphs. This is, by the way, all of this is provided in the IPYNB file for you. You can look at it, and you will be able to understand. I've written everything in text cells. Okay. Now, what are we doing here? Let's go back to the data set. Yeah. Okay, so we know the structure of the dataset has already been split. So we don't. The greatest thing about learning from the MNIST datasets is we only need to worry about the model. We do not need to worry about splitting the datasets. So as you can see, this dataset was already split. We just use the tf.keras. And by the way, try to run the program side by side. Right? tf.keras.datasets.mnist.load data. Okay, so tf, what just happened here? So tf, again, as I said, TensorFlow dot keras is just a sub module inside a module, right? So you go by dot. This is just going inside a folder, inside a folder, inside a folder. So you're just going to datasets, and through which this is the MNIST dataset, and you're using the load data function, which is just going to load the data. Now the structure we already know. 10,000 data points are over here in the test, and 60,000 are here. The total being 70,000 images, right? It's already been split, so we don't need to worry about it. This is the biggest advantage of using MNIST datasets to learn, right? So when we run this, what happens is it downloads from the API directly. Again, we don't need to provide our own images and do anything. Just the simple command just downloads it, right? And it splits it into the 60 10 or 6 is to 1 ratio, right? And then for every data point there's a image and there's a label. Image, label, as we've talked about, right? There are always images which is of 28 pixels by 28 pixels and grayscale, and then label. Now 1 2 3 4 0, right? These are all numbers. So we've now loaded the MNIST dataset. Now we're looking at the x underscore train ka matlab, this is, imagine the data set is being you know this is the images loaded into x underscore train. So every single value from the data set has been put as arrays inside arrays. So for example, I'll just show this to you. Wait, okay, so what happens over here? Okay, so this is the data set. So there are 60,000 arrays. What are arrays? So there are 60,000 arrays like this, right? There are 60,000 of these, and each of them are having dimensions of 28 by 28, right? So this is the current situation inside the X-train dataset. These are some things that you need to do to understand the data. You have to first explore the dataset. What this is doing is just showing you the value for the first data set. If I show you the data, this is how the matrix looks. This is just the first array within this data set, or the 0th array. This is all 28 by 28 values. If you count this, this will probably amount to 28, and then there will be 28 of these. Okay, it's a bit confusing, but there are basically 784, which is 28 times 28 elements divided into 28 separate columns. Right? If you imagine it as a table, it's very easy. Anyways, I'll hide this data. Okay. So now the above line was used by me to get the shape of x underscore train. I just showed it to you. And this shows the image at the first position, right? Okay. So again, there's a question. What would be the unit of 28 by 28? I'm hoping that all of you should be able to answer this in the chat box. Just answer this in 1 minute. We're already running a bit behind because we had to set up the environments. Just answer it in the chat. I'll give you 1 minute and I'll shift back. Just answer anything, right? You can make a guess. Pixel, okay. Bunch pixels, question mark. Come on, use a full stop. Navneet, come on. 784 pixel total. Okay, right. So, anyways, okay, Rajiv, pixels, Purlikara. Yeah. So, you all are correct. This shows that you all have learned something, right? So these are pixels. Okay, now I've what I've used is PLT. Matplotlib is a library which you can use to create. Okay, what's happened? Okay, yeah, okay, this is also great. So Matplotlib is a library which lets you create images or leave images alone for a moment. It lets you create graphs using Python, right? Without having to code every single pixel value. It's already coded in the background. If you want to check it out, you can just go control plus this on VS Code and you'll be able to see the whole library. Right? Control plus click gives you the background of any function, even if you've written it or it's pre-installed. This is why you want to use VS Code. Okay. So matplotlib is a library which will help you show Python plots, right? PyPlot is again inside the matplotlib library. The larger matplotlib library, we've used PyPlot as PLT. Okay, so that the function of pyplot.figure or plt.figure in this case, I'll just use plt, is basically we are just creating a figure with a figure size of 28 by 28 divisions. As you can see in this figure, there's 0, 5, 10, 15, 20, 25, and this goes on till 28. And over here as well. What we are doing is plt.imshow, which is just showing the image, which is xtrain 0, okay, which is the array. Here, right? We saw this data. When you plot each of these pixel values in grayscale, first of all, you have to realize this. CMap is again set to gray in this case. If you plot these pixel values in grayscale, the output should be like this, right? So if I run this, the output should be like, okay, so this, I can recognize this as a 5, right? So now we can again, this was done by me to show you that the figure size can be customized. Okay, it's not necessary for me to use the 28 by 28 only. I can use any other figure size. I would recommend that you're using the correct figure size as defined by the dataset generally. But sometimes what happens is you want to create a a larger image, right? Then you can just change the pixel values in this. When you're using CNNs to, or GANs, which is generative adversarial networks, in which a generator works against an adversary to get better and create synthetic images, right? You can create images of any dimensions by just changing the figure size and a few more things right now. So this was done by this to show you that it's customizable, but you can also use the plt.matchShow function. It does not have as much customizability as the imshow function, but because we have to set the figure for it as well. But plt.matchShow and then just writing xtrain within it will just show the image directly. Right? We won't have to do anything. And also CMap can be set to Viridis, which basically just another type of outputs. Right now we've used gray. If I use this, and you will be able to see. Just a moment. See, this is a different kind of output. These are used for different applications, right? Let's just keep it as gray for now because our data set is in grayscale. So why waste computational power? Yep. Okay. Nice. There was a spelling error. Anyways, so okay. So I've already shown you the shape of X train, right? Now, what I've done here, I'll come back to this. Let's first read about this. What's going on in this? Okay. So again, let's ignore tf.keras, that's just the module name. And tf.keras.layers is again, you just go inside of keras to layers to get dense. Now, first let's talk about what's going on. We've created and a variable. Okay, by the name of model. I can just keep this by any name. I'm not going to change it because I'll have to change every single line after this. But this is just a model, correct? This is just a variable. As you can see, when I hover on it, you get variable model any, could be of any type. Now we've defined it as the type of tf.keras.sequential. So what happens in a sequential model is, imagine a flowchart going downwards, right? So as the flowchart moves downwards, it does every single layer in a sequence. It doesn't do any layer at once in one go, or doesn't do multiple layers at one go. This moves in a particular sequence. So you want it to be a sequential model. So you create it as model tf.keras.sequential model. This is nothing. This has no memory space. I mean, it might have a dummy memory space, but this is nothing. This is not a layer. It's just a type of variable that we have defined. Okay. After this, we are doing model.add tf.keras.layers. Again, we can just ignore this. Dense. So we are adding a dense layer with the activation of in sigmoid and input shape of this. Okay. So let me just switch the screen share to paint for a moment and I'll explain some of this stuff to you. Okay. Yep, paint. Nice. I'm hoping you all are able to see. Okay, so imagine the sequential model as this. You add a layer in this layer, say L1, and then add a layer again, say L2, right? And it will go downwards from layer to layer. Okay, you don't want it to go directly to this. So this is why we use a sequential model. Okay. Anyways, so now let's talk about what is the dense layer. So imagine the dense layer as having a couple of neurons, right? It'll in this case have 784 neurons. Why will it have 784 neurons? I'll just come back to it. Let's just first of all just imagine using this. And then as an output, it'll have 10 neurons. Why is it having 10 output neurons? Because there are 10 values in our data set, which is, 0 to 9, right? We are just classifying it from 0 to 9. So we are having 10 output layers. Now we'll just connect these neurons like this, and every layer will be connected to every neuron. Every neuron will be connected to every other neuron directly. There's no middle points. Now, there are a couple of things that happen. Wait, okay, I'll just make this a bit more efficient. I'll just share the screen. Okay. So now what happens is, uh, in the dense layer, so what is the dense layer? It's just a dense, or it's a heavy layer of neurons. As I just showed you, this whole thing, right? This whole layer is, a dense layer. Anyways, let's come back. So what is going on is the input shape is 784 comma nothing. Okay, or you can just write 0, but I mean 1, but you don't want to write that. Let's not create any more confusion. Input shape basically defines the number of neurons that will be there to receive the first input, which will be 784 in our case. Okay, why is this going on? Okay, so as I told you, it's 28 by 28, right? But we are not using two-dimensional neurons. We can't accept 28 by 28 values. So we just create a single array of 28 by 28, right? And we accept it as 60,000 values of 784. I'll show this to you once again. Wait, see. So what we've done over here is, this is our final, training data set that we'll use. We'll reshape again. What is reshape? Reshape is a NumPy or TensorFlow function in this case, which is being used to, or a pandas function, whatever. It's a function which is being used to reshape the or flatten the value in this case. Okay, we have just flattened the arrays which stored 60,000 images, each of 28 by 28 down to 60,000 images, each of 784 values, which is again 28 ka square. You could have just written 28 into 28 instead of 784, but I mean, why would I do that? Okay, so this is what we've done over here. I'll run this. This will not matter. Okay, so this is showing you the shape in which the input is at right now. Okay, So you can understand this now. This is a lot easier for you to understand. This is why I wanted to come back to this a bit later. The original shape was 28 by 28, right? Again, I'll go to paint. Imagine this. This is a okay. Uh, imagine imagine this as a matrix, right? Okay. Imagine this as a matrix, right? Imagine it as a 2 by 2 matrix, right? Two, two, three, four, whatever. Now we cannot use this matrix as is. Okay, because as I said, this is a single matrix layer. We want the matrix to look something like this. One value over here, one value over here, something here, X, Y, Z, etc. So we flatten this down into a single matrix. Now, how many values will be there be in this matrix in one row? Well, obviously, since this is a 2 by 2 matrix, it will just be 2 by 2 or 4 values. So that's what has happened over here. So the 28 by 28 has just been transformed to 784, as you can see, and 60,000 has no effect on it because this is just 60,000 separate images. This has no effect on it, and we don't have to change white rain. Why don't we have to change white rain? Because it's just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, why would we have to change that? So we've just flattened that. Okay, now let's talk about this. ये मैंने इसलिए 255 लिया है क्योंकि मेरी वैल्यूज एलिमेंट 0 से 255 में है. ठीक है. Okay, so I'll come up over here and show you the data. As you can see, every single pixel value. Okay, so first of all, what are these values? Okay, so all of these values are the values for the amount of white in each single pixel at every point, right? This is 28 by 28 pixels, and each of those pixels have a singular white amount of white की value. That ranges from till 256 or 0 to 255. It has 256 possible values, which are 0 to 255. Now, I do not want my model to be trained on 0 to 255 values because it will take a larger amount of computation to deal with such larger values. What I've done over here is basically normalize the data. Again, I've talked about this in the previous videos, but there was a very complex formula for normalization over there. But as you can see, since we know the data set very thoroughly, we've just you divided it by basically by 255. You can imagine this, right? Any value less than 255 and greater than 0 will come from 0, I mean greater than equal to 0 will range from 0 to 1, right? If divided by 255, right? You can divide any singular value, a single value over here, and you'll get some value in between 0 to 255. In fact, if I can, I think I can show it to you, but I'll just write something over here. I'll, okay, I'll write this. Uh, this will be a bit different from the previous one because this has already been flattened, okay? Okay, so I'll just use. Okay, so see, every single value has been changed to 0 to 1. There will be no value preceding 0 and none exceeding 1. Okay, I'll just again I'll remove this and I'll run this again so that it remains a bit cleaner. Okay, yeah. So you've done that, so the model is easily trained, right? We want the model to be as fast as possible and as accurate as possible. Okay, so now what's going on? We've used activation sim. Okay, so we've understood what is the input shape. It is 784 inputs. Okay, that is the input shape of the dense layer. We've understood the dense layer. Okay, and what is 10? 10 is the output shape. As I told you, we want 10 outputs, okay, which will be, what is the output of a layer, dense layer, right? Right. It in CNNs, it is just the probability of, say, for example, if this was the output of 0, this is the probability of it being 0, right? I'll come back to this in a moment after we've run the model, right? So this is all the out. So this we want 10 outputs, 10 basic probabilities that this has a 1% chance of being 1, 90% chance of being 10, etc., etc. Okay, and the activation function is sigmoid function. Okay, so I think some of you might know the sigmoid function, but in just in case you do not know, sigmoid function is basically I'll show you the diagram in a bit, but what is an activation function you first need to know is basically what defines the output of a neural node. Okay, it determines if the next node should be activated. Okay, so what will happen over here is, say there are nodes, right? There's a dense layer, and then there will be dense neural, again, hidden layers inside, right? There's one input layer and one output layer. So they'll be going to this, 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 this. The activation function will decide if this neuron needs to fire or not. It may say, okay, this is not necessary right now. Just fire this, and this will give the output. This will not give the output because every single one is connected, right? But we don't want this value right now to affect the output. So it will take this output. This is a very important aspect. This is the first thing that you learned is which was somewhat difficult, right? So again, activation functions can be many. There are many activation functions, right? Sigmoid or ReLU. And again, if you guys have any doubts, please just interrupt me for a bit. Right? I have no idea if you're raising your hands because I'm not able to see. Okay. So, anyways, there can be a few functions. First is the sigmoid function. The other I've already given you the diagram over here. I'll come back to it later. ReLU, right? Leaky ReLU, etc., etc. So first I'll show you the sigmoid function diagram and formula. Okay. So this is the sigmoid function diagram. Okay, so what's going on over here? If you've made any form of logistic regression model, this is also a function. So the basic value of the function is this. For every value of x on the obviously the x line, you use this function, which is just 1 by 1 plus e to the power minus x. Why do we do this? Is to, again, every single activation function is used to specify if a neuron should be fired or not. If we just plot x and find it out, then it would be a linear regression model. We do not want that for a deep learning model, right? That would just defeat the purpose. Imagine if s of x was just mx plus c. We would just plot a single line, like, right? We would just plot a linear line. Okay, I think I've already plotted, right? This would be the value of mx plus c, and this is a function put on it, an activation function being used. It brings non-linearity into our model, which is much better than a single linear function. Otherwise, we won't be doing deep learning. We would just use linear regression, right? So how to change linear regression models into deep learning models? Used activation functions, which are nothing but mathematical functions, using which we can plot a graph. But in this case, we are just using mathematics of that function, right? Okay, then there's a loss. What is the sparse categorical and cross entropy? Okay, so first of all, I've got this written down. What is cross entropy? Okay, so cross entropy is basically the difference between the output and the input in very easy terms. Okay, so I'll just show it to you guys. Just a second. I think. Uh, okay, so these were all questions I've already answered. Anyways, so cross entropy. Let's come back to cross entropy. Cross entropy is basically the difference or the loss that you want to generate. And then categorical is because we are using separate categories, and sparse is we create a sparse matrix. Sparse matrix, just in case you didn't know, is basically a mathematical matrix in which most of the values are empty. Okay, so see, this is a sparse matrix. This was an empty matrix. We create a smaller matrix which we can, first of all reduce the computation power, and then again enlarge this matrix to create the old matrix but use less amount of memory. This is why sparse matrices are used. So the loss will be generated by this function. Again, how do you find these functions? Very, very easy. You go to, well, I'll just show this. Okay, control C. You go like this and then go to TensorFlow. As you guys should be able to notice over here, tf.keras.losses. This is how we've been using our TensorFlow functions. So you can find the direct side on the TensorFlow official sites. So this is just one like sparse categorical cross entropy, right? So it predicts and y true, right? It takes the actual value of y and the predicted value of y and then calculates the cross entropy for it and then creates a sparse matrix out of it to save memory. So this is also what we are trying to use, right? And categorical is just for it can do separate categories at one go. Okay. And these are all the losses if you can see, and you can see the overview over here. Yeah, if you go to the overview, you'll get to see all of the functions and all of the losses. And this will be very helpful for making a model. Just in case you want to see, okay, I want to use mean absolute error. It will tell you that computes the mean of absolute differences between labels and predictions. Okay, again, mean absolute error will just show you the average of, like, for example, if the label was 1, prediction was 0, it will just go 1 minus 0 by whatever, 1 in this case. And then add all of them, just giving you the absolute mean. Then you have the mean squared error. We've taught you about this in the previous classes. So all of these errors are pre-built. Of course, you can code these out using the formulas, but you generally use these, right? I can code every single error out. I just need to know the mathematical formula. Even the optimizers I can code out, right? So this is one thing that you should have understood. Okay, so what are optimizers? So once you've created a loss, okay, how is the CNN working? It's gotten some values over here and it decides a function f of x to get the probability p of y. Okay, so now this f of x is what is to be changed. This is what is to be optimized. So based on the loss generated by the p of y being incorrect, right? We change or optimize the f of x. And for that, we use optimizers, and in this case, I've used Adam. Okay, Adam is the name of an optimizer. Again, I'm trying to show you guys how to use the documentations. Adam, you can just search optimizer and go tf. Okay, so tf.keras.optimizers.adam. Again, you've gotten to the Adam and you can go to an overview, right? This is all, by the way, these are all the default values, so we don't have to define them. By default, it has 0.01001, I mean, learning rate, beta 1, beta 2, epsilon, etc. You don't really need to know the very, very deep uh, basics of Adam, but you need to know what it does. So you can just go to overview and then you can see all of these optimizers. Optimizer that implements the Adam algorithm. For this, you can just look it up and go Adam algorithm. Then you can see it is a popular optimization, which is based on stochastic descent. Anyways, okay, so you can learn about this. So I'll just explain Adam to you in very brief. Okay, Adam I've got written down again. So what is Adam basically? Okay, Adam is basically it uh, computes adaptive learning rates for each parameter and keeps moving averages of past gradients and squared gradients. What's just happened? Okay, so Adam basically will compute the error based on the losses and then create a gradient or the change, right? What is a gradient? It's the change. And then create a change based on that error and the past changes. And then it will slowly make the model better or the function better. Okay, so for example, let's take a linear function, right? Y is equal to mx plus c, right? Now we can tweak the values of m and c, right? So based on the values of m and c, we can introduce non-linearity. So it will be some other function y is equal to x square plus e to the power something, and then it will change the function based on the optimization, which in our case we've used Adam. Okay, So, and the metrics is accuracy. It'll, use accuracy as its metrics and it'll show us the accuracy while training. Okay. So in the previous cell, we've used sigmoid function. Sigmoid function is just to, make the argument softer, or in other words, introduce non-linearity. Okay, so instead of sigmoid, we could have used ReLU, and I've not used this because this would have created a lot of issues. I'll show it by using it once. Okay, so I'll do ReLU and then I'll run this. And ReLU is generally a better, by the way, better activation function than sigmoid. But what will happen over here is I'll use it for, okay, I'll use it for, say, this. While it's running, you can see the accuracy as being 1.7. Sorry, 17%, 15%. Okay, right. And yeah, I just interrupted this because I didn't want it to run for so long. Anyway, so and ReLU is generally a better function, but what happens with ReLU is, why don't we use this for very simple models? First of all, you can see that we only need to use a pre-processed perfect data set in this case, and we are trying to learn the very basics. So, this has only one layer, which is the dense layer. If you see general CNNs, it will go with model.add, right? Max pooling, right? And it might add on 2D, which is a convolutional two-dimensional layer, etc., etc. Right? So for these cases, we use ReLU. What does ReLU do? Okay, so I am going to teach you about ReLU a lot because this is what you will use in real life. Okay, so ReLU, which is first of all rectified linear unit function, is used to bring again non-linearity to our function. This helps our models with the vanishing gradient problem. So first of all, before I answer this for you, I want to know if all of you have understood everything. Just in case you haven't, I'll just stop for a moment and I'm waiting. I've come back to the meeting screen. You can raise your hands. Okay, Nikunja has understood. Shlok has understood. Daksha has understood. Okay, so I'll move back. Um, okay, so anyways, Uh, okay. ReLU basically, okay, so what is the vanishing gradient problem, first of all? When your model is being optimized, right? So again, we are using activation functions. So when your newer neurons are being activated, in case you use ReLU, what would it do? Wait, control. Okay, so what would happen if we use ReLU? So when you're activating newer neurons, you're creating losses, right? As the losses go down, see for example, right now it's 2, and then for after a while it will come to 0.2, 0 point something, and if the overall loss is 2, but inside the values come to a very grinding halt. For example, they reach near 0. So what happens in this case, when it reaches near 0, the real line might be right here, right? This may be, imagine this as being non-linear, linear. So this is just a singular line and they reach near 0 and then activation, stops and the gradient vanishes and losses vanish. They go away and the model stops becoming better. What ReLU does is it applies a function on top of the linear function and then creates the, creates this. This is the graph produced by ReLU. So what happens is even if they're close to 0, this still provides some activation and some losses, right? I'm hoping that you guys are able to understand this, right? So ReLU is popular in hidden layers. So the as the amount of layers increase, we use ReLU more often and often. ReLU is the most often used, by the way. It helps the wave with the vanishing gradient problem, and only issue is it can cause dead neurons, which is basically it might see some neurons as totally unbeneficial and just stop using them. Anyways, so we are using sigmoid again. because this is a very basic model and we do not need to use ReLU. As you can see, the accuracy is very, very low because the learning rate becomes lower, right? It could just be learning with the sigmoid function. Instead, it's learning with activating with the ReLU function. I'll run this again and then I'll run this again. Now you'll see the accuracy will start in and of itself from something close to 80%. Okay, so it's 68, 80, right? So it's already 80%. Again, this is since this is a decimal, to get the accuracy, you just multiply by 100. So it's 80%, 91%, and let's just let this continue while we talk a bit more about this. And I'll come back to the meeting. Meanwhile, you can just ask questions, right? So go on. If someone has any questions, they can ask me. If no one has, if you don't have a question, just give me a thumbs up so that I can see that they're sort of here. Okay, Yashansh, Taksha. Okay, how would we know what activation function or optimizer to use for our model? Do we hit and try to find the best one for us, or is there a best one for each type of? So first of all, there is a best one for each type of model, as I've shown you. When you go to the TensorFlow website, you can see what every model does. Once you've understood the basics of the models, you will be able to understand. So why didn't we use? I have already taught you mean squared error. Why didn't we use mean squared error? Why did we use this? Because we had categories and I wanted to use cross entropy between them. I didn't want to use mean squared error. So, and I've already told you that the best one to use for linear regression is mean squared error. So as you can see, there are very particular uses for each and every type of optimizer and activation functions, right? You can do hit and trial. You can search your type. For example, you're creating a CNN for a problem. You can search on Google, okay, this is my problem. Which one should I use? They'll tell you. It will probably already be answered. Okay, so this is already run. We'll come back to that in a moment, right? So for that, you and but okay, so you can search on Google, but you should do hit and try. So 2 3 models, you'll start to understand, okay, this is the general activation function and general what is that, optimizer to be used. But once you put them, and as I showed you, right, I showed you correctly, the general optimizer to be used was ReLU. Once I put it, the accuracy was coming out to be, zero, starting from 0.1. It would have reached 93, but after maybe 2000 epochs, maybe 3000 epochs or whatever. But I said, okay, let's try with sigmoid. And if you use the advanced mathematics, you won't be needing to use hit and trial. But for basics, for beginners like us, right, we need to use hit and trial. We write a sigmoid function, right? And then we see, okay, the accuracy is increasing. And it's just not hit and trial. You have to make an educated guess and make it better. That, okay, so in this particular problem, which is the most efficient one, the sigmoid one will be efficient because why? There's only one layer, so there is no vanishing gradient problem. It just gets an input, does some functions on it, and gives an output. There's no other forms of layers in between, right? So I'll just use the sigmoid function, right? If you've made a linear classification model or regression model, then you'll also realize from there. Is that okay, Navneet? You can just give me a thumbs up. I don't know. I'm not able to see. Anyways, I'll continue. So this is how the model was fit. Okay, so again, what is this line? Dot fit is again a function of the sequential type of TensorFlow models, right? You're just fitting the training final data set. This is all the already flattened and normalized data set. You can see the shape, which is 60,000 images of 784 pixel, values, not pixels right now. And Y-train is the label. We didn't have to do anything for Y-train. We've trained it for 20 epochs, and the last accuracy of our model was 93%. Now, what does this do? Okay, so there are 3 ways. You can save the model by using model.save_weights. You can use the save model function, which will save the model directly. You just have to then define the model and not use it. I'd like to use the save weights function. What happens for the save weights function is, till here you have to run the program, and after that you don't have to do this because obviously you're using that, and you just use load weights. I'm just going to run the save weights function, and it's just going to save it. And where is it saved? It would be saved over here in this my model. I can name up to here, right? Dot slash is basically just use the directory I'm currently in, and then the name I want to save it as, let's just change it as trial, and I'll save this. Right? It should be saved. It will come over here in a bit, right? So yeah, so it's over here, trial.weights.h5. Anyway, so this is the loading weights. I can load the weights, but it's since it is already trained in this instance, I'd have no need to load the weights. You can just, when you're using, you can just click this and it'll load the weights. Instead of running this, you can run this after you've downloaded this file as well, and it'll load the weights, and you won't need to train it. Okay. So again, I've again reshaped the X test function, right? A part of the dataset to the amount that it'll be able to accept. And first of all, what we do with len of X test, and we also used it for len of X train. So these are just the length, or 10,000 in the test case scenario, and for training it was 60,000. So this is just the length, that we have 10,000 values of size 784. So original again 10,000 comma 28 comma 28, which can be seen over here, right? It is 28 comma 28, and the split is 10,000, right? Okay, and the X test final will now be again 10,000 comma 784, as can be seen over here, right? Now flattened, I've again normalized it. You might want to do this, but since I've trained it on a normalized version, I'll just normalize it again, since it's just one line of code. I would suggest doing it without this and seeing if an error comes and which kind of error shows. Now over here, instead of using the whole customizable command, since I don't need to really customize, I've just used, plt.matchshow x test 0. So this just shows that the first image in our test variable was 7. I mean, I'm able to see this. I don't know if my model will be able to see. Now, this is just to prove to you that the model is working. Okay, we are just proving to ourselves. It should be able to accurately define this. This is 93% accurate. So we'll see how accurate it is in real life. So predict is again just any kind of variable, right? Model.predict, again predict is a function. This is just putting the all of the values, 10,000 values of X test final flattened. Okay, just put this in, and it is now predicted. Now this is the prediction value. Okay, so what happened here? As I told you, the prediction will be of type probability, right? We've already talked about this over here. These are all the, okay. So these are all the predictions, probabilities of, for example, let's say this was the output for 0, 1, 2, 3. So it will give the probability in decimals, but I'll just write percentages for you to understand. Let's say that the number was 2 and our model is 100%, 100% somewhat accurate. Okay, so it will go, okay, so 2% this, right? Then say 3% this. This is again probability of it being 1, probability of it being 3, the image being 3 or 1, and then it will go, okay, probability was you know what is it, 95%, the remaining, right? So it is 95% sure that this is the one, and it is 2% sure that it is 1, and 3% sure that it is 3. If our model was 100% accurate, it won't show this, it won't show this, it won't show this, it will just go 0 and 0 and just go 100. I know the handwriting is a bit bad, but it's paint. So yeah. Anyway, so these are the values, right? Now, if we can see this, so this is the probability of it being 0, 1, 2, 3, 4, 5, 6, 7. As you can see, 7 is very, very high, right? 8 and 9. So now, since this is run, output is okay. So what is NP? NP we've already got NumPy. NumPy is what? Just array making and array manipulation library, right? It gives us mathematical functions for arrays, which are just multi-dimensional and multi-valued variables. Okay, so now we are doing predict 0. Since predict has, all of the values predicted, this is just the first element, which is supposed to be 7. Hopefully the output is correct this time. So we put it inside output variable, and then when we print output, it is 7, where it gave the maximum argument. So the maximum argument was 7 from this array produced. So it is capable of producing 7. Now, since let's just check it out if this is not a fluke. Let's give just use a random number, say 5. So the fifth element is 1. Okay, so I think this might be inaccurate since the 1 is tilted, but I don't know. So again, we'll predict it, right? And then we'll use predict. Okay, no, wait. We'll give this will also be 5, right? So we'll do predict ka 5. Okay, so it has predicted it correctly. I mean, I'm already able to see this, but we'll just go over here. We give it to output, and then once we print the output, it is see, it is not capable of producing it. Oh, wait, no. Okay, I was incorrect. Yeah, so the model has apparently outperformed me, right? So it was capable of predicting it as 1. You can test it out for various values. Let's say there are 10,000 values, right? Let's go 999 or 0999. So once we go 999, should be giving us something. So this is a 9. And okay, again, you don't need to run this again and again. I'm just doing it out of habit. You go, what's the value? 999. So 1, 2, 3. And then once you produce this, the last value should be the greatest. I think it is, but this might also, it might be confused between 8 and 9 or 7 and 9. I don't know. We'll see. This is the correct value, right? Yeah. Okay, so see this one confused the model. Why has this happened? Because the accuracy was not 100%. So this happens sometimes, right? Again, if we turn it back to say 5 and 5, we run this. This is supposed to be, I think this was 1, and then I don't need to run that again. I'll run this. I'll just go 5 and then print the output, and it's 1. So you'll never achieve 100% accuracy, but it will be able to predict most values. And you can, upload your own data sets in this as well. I'll just show something to you as to how to load your own data set. Obviously, you can use ChatGPT to learn it as well. I mean, you just type it, I want to load this into a 28 by 28 version. It'll be able to show it to you. But let's just come back. Okay, Navneet got it. Nice. Uh, Let me just open this up. Just a second. Okay, so this is how the this is why we use this will show you why we use the mnest function, mnest dataset to learn the very basics. So this is our general image loading function looks like. So this is the data load function. You define the folder path. This is the images. You use the OS module to list the directory, which is just you're just listing every single values in that path. And if it is a JPEG or JPEG, right, you could also use .png, etc. You can join it and then open it and then resize it to the size you want. Again, all of this has been done by TensorFlow for us for the MNES dataset to 28 by 28. In this case, I am resizing to, let's say, 28 by 28 only. Right? Right? You can do this, and then you have to transform it into an array with NumPy, and then convert it into a TensorFlow tensor. Right? So all of this you have to do for just loading the data if you're doing it manually. But in case of this, you don't need to do that. Okay. So I think that's all from my side today. I'm hoping that all of you have downloaded this, cloned this repository. Okay. So thank you. If anyone has any questions, you can ask me. We'll be ending in a bit. I'll just wait for your questions if you can ask me. You can obviously ask after the class as well in case you don't want to ask right now, you're shy as well. And if a doubt arises later when you're performing it and tweak the model according to yourself, you might want to try to add one more dense layer. And then you'll see that sigmoid function is starting to give problems because the loss has gone away. Loss is not being generated. So yeah, if no one has questions, I think we can end, right? So I think
Oh,
okay,
I had
Shiveen.
a question. Yeah,
Yeah,
I
yeah.
had a question. Can we make the model train on itself? Like once we train the model, after
Mhm.
then we are collecting the outputs. Uh, we give it a image and we get the output. Based on whether the output is correct or not, can we make the model train on itself
That
in
okay, okay,
any?
okay, okay. So this is a very basic route. Okay, so when you train a model, right, Shiveen,
Hmm.
what happens is you remember the model dot fit I went X train and Y train.
Yes.
Why did I give you X train and Y train to the model? I gave both because how does the model train? It trains in the exact way that you've just explained. It will predict for X train using the functions, then it
Hmm.
will generate losses, and then it will
Okay.
optimize based on the error from the output. This is how it's training on itself only. This is what the whole model trains on itself. So what
Got
you've
it.
just
Got it.
defined is how it's learning, right?
Okay. Got it. Got it.
Yeah, yeah,
Thank you.
yeah. You're welcome. Thank you. Uh, Anyone else? You can ask any form of doubts. So I think everyone's doubts are clear. If some other doubt arises, ask on the chat. Maybe I'll answer. Maybe someone else will. Or it should be correct, right? I think okay, Nikunj is writing. For this image classifier using CNN, do we use ReLU or Sigmoid for least errors? Okay, so first of all, you don't use it for least errors. You want there to be errors. You don't want, okay, so you don't want runtime errors, but you want the errors for your model, right? I hope we are clear on that. These are the I'm talking about ML errors when I'm talking about this. When I say errors will arise, those are Python errors that something went wrong. Anyway, so for the image classifier, in this case, I'm using sigmoid because, as I showed you, we achieved 93% accuracy when we were, already in what is this thing, only in 20 epochs, which is 20 training cycles. But this was only possible because we used the sigmoid activation function and we used it on one layer. If you use the sigmoid function, it will work. Not recommended by me, but it will work on more layers. But as you add more layers to make it more accurate for larger problems, because the MNIST dataset is very optimized, na? It's given you everything, and real world datasets won't be like this. This is a real world dataset, but it's been made to teach. It's in fact, if you read the description of this dataset, yeah, like you can ask ChatGPT to describe this. The purpose of the dataset itself was to be made for teaching only, and for making models which can recognize handwriting. Obviously, handwriting, that is kind of obvious, but this is the starting step. So you can use this to learn. And for this, in this particular model that I've made, I've used sigmoid to increase the accuracy in one go. But generally, when using models, you use ReLU. You might also use leaky ReLU. That is a separate function. It is based on ReLU, just a way more advanced version. You have to realize, once you try to make the model more and more accurate, you start to use more and more complex functions such as ReLU or leaky ReLU. So the time for it to become accurate would be a lot longer, but at the same time, it would be able to achieve a higher amount of accuracy in the end. Okay. So this, I cannot answer ki ReLU ya sigmoid. In this case, I use sigmoid. If you see YouTube videos, they might also use sigmoid, but if they use more than one layers, they might shift to ReLU. Okay, Nikunj. You're welcome. Thank you for asking. And also, I would recommend that you guys, since you have the code, just change it and do whatever you want with it, play around with it. Okay, so if anyone else doesn't have a doubt, we'll end. But if someone does, please ask quickly. Okay, I think thanks. Okay, thank you for joining. It was a pleasure, right? So, thank you, Shiveen. Thank you for joining. Thank you, Shlok. Thank you, Shiveen. Thank you, Nikunj. Thank you, Tushar. Thank you, Yashansh. Thank you, Aniket. Right? Thank you for joining. You all can leave right now. Okay. Thank you, Shiveen.